It's a weird feature, but if you're looking at 1 to 6, you can basically do a sixth. 1 plus 2 plus 3 plus 4 plus 5 plus 6. The outcome is 3.5.
And that's the same as finding the mean.
Yes, so the mean of a dice roll is 3.5.
So if they all have the same probability.
Yes. Yeah. All right. This example here. What's the value of A?
Oh, that's like 5.5,
5 on 10 or a half? Yeah. Some people do this quick math. I'll go for a common denominator. So that's 4 on 10. 1 on 10 is 5 on 10. That has to be the other 5 on 10 or a half. Not too bad. The mode. What's the most likely?
3.
3. Nice. 3 is the most likely. And then we'll do the mean. So here, the mean is the sum of all xi pi, which is going to be 1 times 2/5 plus 3 times a half plus 5 times a tenth. And in this case, we can't do a fancy factorization. It's not a uniform distribution. So we're just going to have to work it out. That's 2/5 plus 1.5 plus a half. So what is that? 2/5 plus 3 on 2 plus a half.
That's not a half.
That's not a half. They make 2, so it's 2 and 2/5. 2.4, 2 2/5. Again, you've got calculators, so you don't have to mental arithmetic too badly. On the note of calculators, would you like to know how to do this on your calculator? Yeah. All right. Open up your calculator.
Whoa, whoa, whoa. I got it. That's like the physics formula. No, it's not. Oh, it's just like what? Oh, yeah, that is what are you in?
Alrighty. Oh, come on. Can you guys go to stats mode, please? So, number 2, stats mode. And delete whatever's there. Alright. Now, what we need to do is put in both lists. So one the outcome list, one the probability list. So the outcome list is 1, 3, 5, and you wouldn't do it with such a small one, but if you had 8 or 9 different ones, it would probably be easier to do it in this stats mode. Then you need to do the
2 and 5.
Yep, and 0.1. Cool. Now, you can think of this as an outcome and a frequency, or an outcome and how often the outcome occurs. So in past years, you might have done outcome and had whole numbers here as a frequency. We want to calculate what we want to do about this. So we're going to do, press the calc button. You're after calc. So F2 down the bottom there. And then we've only got one variable here. One variable. But before you click one variable, we're going to click set, because we need to tell it what we're about to do. So click set. And you need it set up like I've got here. Your frequencies are in list 1. Sorry, your variables are in list 1. How often they occur is list 2. So you need list 1, list 2 there.
Why would it not already be like that?
Some of you might have 1 as a default, meaning it occurs once each.
Do you have to change it each time?
No, I would always put them in that order, and then your settings set. Alright, if it's like that, click exit, and then hit 1 var. And Importantly here, it tells you X bar. X bar is your calculated notation for the mean. The mean is 2.4. We found it manually already. Great. Also, interestingly, it tells you this is the standard deviation, which will be of more use later. And standard deviation is not simple to calculate by hand, which is why we'll often reach for our calculator to do it. So, mean, standard deviation are the two you're more interested in. Alright, moving on. So, a fair game. I've mentioned this concept already. A fair game is one where nothing is lost or won. So, another way to state a fair game would be the expected value is 0. And an example of a fair game would be playing rock, scissors, paper. Winner gets $10, loser gets $10. Assuming it's equal. Do you want me to say rock, paper, scissors?
I would love that thing.
Why'd you do it?
I always play rock, scissors, paper.
No, it's not.
Alright. Assuming we're playing the same game and no one's cheating, that should be fair. There are many famous games like blackjack, roulette, pokies that are famously unfair.
Green.
They might only be unfair by a little amount, like roulette, the green square makes it unfair, but they're still unfair. Alrighty.
I'm gonna sell a kidney to
So, a man rolls a regular 6-sided dice. Regular meaning it's got a uniform probability distribution, so they're all equal chance of occurring. He wins the number of dollars shown on the uppermost face. Find the expected return from one roll of the dice. We've done this already. It's 3.5. So you'd expect to win $3.5 from one roll of the dice. What is the expected gain if it costs $4 to play?
Negative 0.
0.
Yeah, negative 0.5. So in terms of expectation, we can have negatives in there. His expected gain from playing this game is negative for $0.50, negative 50 cents. Would you advise the man to play mini games?
Yeah.
No, of course not. All right, and that is all you need to make a start on the next bit. Shouldn't be me talking too long. Don't do every single one. I've cut a few out, but by next lesson,